Welcome to all. Now we will discuss Varactor Diode. It mainly operates in reverse bias. You can represent either in any manner like this. These are the symbols of the Varactor Diode. And if you see the characteristics, if the voltage is increasing, go on increasing, the capacitance is go on decreasing. Okay, this is the characteristic of the Varactor Diode. And coming to the formula, Ct is equal to Ct naught by 1 plus Vr by V naught of 1 by N. Here Ct naught is the junction capacitance at 0, whereas Vr is applied reverse bias, V naught is the built-in potential. Okay, this is the formula of the capacitance regarding the Varactor diode. And you can also call Varactor diode as varicap or epicap or hot carrier diode or voltage variable capacitor. Because of this voltage variable capacitor, you get the application. The first one, that is, it can act as a tuning capacitor. Okay, you may ask the question, why Varactor diode is called as a voltage variable capacitor? Means it acts as a tuning capacitor. You can tune, by tuning the capacitor, you can use it in FM generation or in radio receivers. Okay, so these are the application. And next one is, it is a reverse bias diode and its capacitance depends on the junction depletion region. And coming to the reverse bias, if you are having the large reverse bias, obviously you will be having the wide depletion region. If it is having the small reverse bias, it is having the narrow depletion region. Here the Cin is inversely proportional to the reverse bias voltage denoted as Vn. And one more important point, the application for this is, it is suitable for ICs of 3rd and 5th, 3 to 5. And next one is the, here the material used is, you can use the materials either silicon or gallium arsenide. If you use the gallium arsenide, it gives the better frequency response. So at microwave frequencies, Varactor is not useful for oscillators. It is very important point. And Varactor diode is the device associated with voltage controlled capacitance. Okay, now we will see the applications of the Varactor diode. The first one is the, it acts as a tuning capacitors and it is used in radio receivers because of the voltage variable capacitor characteristics. It acts as a frequency converter and tuned circuits, and it permits remote tuning. And last one is the step recovery diode, is also known as snap off Varactor. And that's about the Varactor diode. You can expect these points from the as a MCQs regarding the Varactor diode in different competitive exams. Now we will discuss Schottky diode. It is used primarily to prevent saturation of transistors, and this is the symbol of the Schottky diode. It is similar to the PN junction diode, but you need to draw like S shape. Okay, it becomes the Schottky diode. So the barrier potential is 0.25 volt, and for silicon it is 0.3. That's why the barrier potential is 0.25 in Schottky diode. And here the minority carrier storage time is 0. It is having no minority carriers and very low voltage drop in the forward direction. Okay, the voltage drop across the diode is 0.25. Okay, for PN junction it is the 0.7 volts. That's why you are getting the cut-in voltage 0.7 for the PN junction, whereas for Schottky you will be getting only 0.25 volt. It is very advantage compared to the PN junction diode. And coming to the application point of view, it acts as a high frequency switch and rectifier. You may ask the question in the MCQ that which diode acts as a high frequency switch and rectifier, means it is nothing but Schottky diode. And the metal used here is the silver, and the Schottky diode turns off faster with respect to the PN junction diode. It is also one of the important MCQ. Now we will discuss the fifth one, that is photodiode. Photodiode, actually it converts the light energy into the electrical energy based on the photovoltaic effect. Okay, when light increases, reverse current in photodiode increases. This is the symbol of the photodiode. So it is converting the light energy into the electrical energy, and it operates in the reverse bias diode. and it is used to detect the light, and it consumes electrical power due to incident light. Okay, incident means the coming light. To charge auxiliary batteries, which diode you will be using means for photodiode. And to read a film soundtracks, which diode you will prefer means it is photodiode. And sensitivity of photodiode depends on light intensity and depletion region width. Okay, that's all about the Schottky diode and the photodiode. In the coming up videos, I will cover the remaining diodes. Thank you so much.